Algebra 3, Chapter 6, Section 6, Inverse Trigonometric Functions. Remember that a relation, in order to be a function, has to pass the vertical line test, which all of our trig functions do. That's why they're functions. However, for the inverse of a function to be considered a function, the relation must pass the horizontal line test, which none of our trigonometric functions do because they're periodic, so just by definition they can't. In order to deal with the inverses as functions, what we're going to do is we're going to limit or restrict their domains. Remember, we use the inverse trig functions when we know the value of the function, we need the value of the. There's two ways to symbolize the inverse sine function, really all the inverses. You can use the word arc, y equals arc sine of x, or you put a little -1. It kind of looks like a power, but it's not. It does not mean reciprocal. In order to mean reciprocal, you'd have to put parentheses around the whole sine of x and then put the -1. Written like this, it means the inverse of the sine. The definition is that the inverse of a sine, y equals arc sine of x, if and only if the sine of y equals x. In other words, x is the value of the sine, y is the angle. Where -1 is less than or equal to x, which is less than or equal to 1. That was our range for our regular function. Remember, inverses swap out domain and ranges with their inverse. So for sine, your range is -1 to 1. For the inverse sine, the domain is -1 to 1. We restrict the domain of the sine to -π/2 to π/2 so that the range of its inverse is -π/2 to π/2. Okay, and this is what it looks like. The reason we restrict it there, we can't do it from, say, 0 to pi, because then we would only be including the positive y values. So we go from -π/2 to π/2 to ensure that every y value, every value for the sine, every potential value is covered, both positive and negative. Now, there's going to be a little bit of variation among them. Each of the others can be symbolized with the arc or the -1 notation. The restricted domain depends on the function. So here's the deal. The sine, the tangent, and the cosecant are all going to have the same range, which means they have the same restricted domain. The inverses will have the same range, same restricted domain. The cosine, the secant, and the cotangent will all have the same. So for arc sine, arc tangent, and arc cosecant, the range is going to be -π/2 to π/2. For cosine and cotangent and secant, it's going to be 0 to pi. Okay? And again, the reason for the sine cosine is because of where the positives and negatives values for sines and cosines lie. For tangent and cotangent, it actually, what we've done is we've taken one period between two asymptotes for those. The reciprocals, except for cotangent, have the same as their counterparts. So this is the domain and range for our inverse functions. It is important that you understand where these functions are restricted. When you use your calculator, it will give you back answers that are within the restricted range. Okay. Here are what the graphs look like for sine, cosine, and tangent, for the inverses of sine, cosine, and tangent. And here we have the graphs for the inverses of secant, cosecant, and cotangent. Secant and cosecant are a little weird. Okay, composition of functions. If -1 is less than or equal to x, which is less than or equal to 1, and -π/2 is less than or equal to y, which is less than or equal to π/2, then the sine of the arc sine of x equals x, and the arc sine, the sine of y equals y. And then it says a similar thing for cosine. Here's the deal. When you compose a function that's inverse, generally it gives you back, they just kind of cancel out. And the same is true for the most part for the trig functions, but sometimes a little wrench can be thrown into the works by the restricted domain. Now, if the inner function is the inverse, everything's fine. It's when the inner function is not the inverse that it can get a little tricky. And we'll probably see how that works. So the inverse properties only work for the domains and ranges given. Now here's an example. The arc sine of the sine of 3 pi over 2. Well, you might think, okay, well, they cancel and give me 3 pi over 2. Well, no, because the 3 pi over 2 is not in the restricted domain. So what you're going to do is find that the sine of 3 pi over 2 is -1, but the arc sine of that is negative pi over 2. So it's got to be an answer that's within the restricted area, the restricted value for angles. Okay, so that's kind of the tricky part. If the inverse is the inner function, if the inverse is what you're doing first, it's not a problem. They just automatically will cancel each other out. But a situation like this where it's not the inverse down there, you've got to really be careful and make sure that you give an answer that is within the proper range of acceptable values for the angle. Okay. Calculator to evaluate the expression. Now, this is where you can use the second button, okay? So you're going to do second cosine 0.37. These, I do believe, are in radians, so you do need to make sure you're in the right function first, in the right mode. Okay. Pause the recording, give this a try, and resume to check your answer. Okay, if you didn't get any of these right, yeah, probably just a calculator. You should probably put something in wrong. Make sure you're in radians. Make sure you hit the second button and then the appropriate function. On this one, we're going to determine the missing coordinates. Now, this is kind of using our knowledge of special triangles. You know, the y values, remember, this time are the angles. The x values are going to be the tangent values. Pause the recording, give this a try, and resume to check your answer. So the arctangent of -3 is negative pi over 3. In other words, the angle that gives you a tangent of negative square root of 3 is negative pi over 3. For the second one, the tangent of negative pi over 6 is negative square root of 3 over 3. And the tangent of pi over 4 is 1. Okay, use an inverse trig function to write theta as a function of x. In other words, what you're going to do is, for the first one, you've got the opposite and adjacent. You're just going to write the trig function that uses opposite and adjacent of theta equals, what it equals, and then you're going to actually write it using the inverse. Pause the recording, give it a try, and resume to check your answer. Okay, so look what we did here. We said tangent of theta, I was trying to explain it without giving too much away, is x over 4. Which means that theta is the inverse tangent or the arctangent of x over 4. So if you didn't quite get it the first time, pause and see if you can do it to the second one. This time we have the adjacent and the hypotenuse, so we'll use cosine. And so cosine of theta is x plus 3 over 2x, which means theta is the arc cosine of x plus 3 over 2x. All right, now use the properties to evaluate the expression. Pause the recording, give these a try, and resume to check your answer. This is a positive, so it's going to give you an answer. They're just going to cancel out. It's no big deal. Okay, what we need to remember, excuse me, is the sine of 3 pi is 0, and the arc sine of 0 is going to give us 0. So this is a case where they don't just cancel. Now what I suggest you do on here, and you see the hint, sketch a right triangle. You know the tangent's 3/4, draw a triangle and make the opposite and the adjacent 3 and 4. Pause the recording, give it a try, and resume to check your answer. Okay, you see here we've drawn, and we did it in the first quadrant because tangent, arctangent, inverse tangent is going to be limited either to the first quadrant or to the fourth quadrant. It's going to go between negative 90 and 90, or negative pi over 2 and pi over 2. So we're drawing this in the first quadrant since it's positive. Labeled it, found the hypotenuse, and sine is 3/5. For the second one, you could do the same thing. Here they just kind of reasoned through it, but you can do the exact same thing. Draw the triangle, find the missing side, and oh, there's the triangle, and you can find the cosine. Do the same thing for these. Think about where the function for the first one is going to be negative. Pause the recording, give it a try, and resume to check your answer. Okay, here's our triangle, and this is going to be in the second quadrant, which is where the cosine is negative. So we drew it there, labeled it, found our missing side. The sine is the square root of 5 over 3. Second one's a little tougher because you have an x involved. So the tangent's x over the square root of 2. We need to find the hypotenuse, which we use the Pythagorean theorem for. It may have thrown you a little bit not having a number and having an x in there, but really you don't change anything. And then we just write down the cosecant. Again, sketch a triangle, same thing. This is similar to the last one we did. Pause the recording, give it a try, and resume to check your answer. Okay, if the tangent is x, it's x over 1. Find the missing side. Actually, you don't even need to do that for this one. The cotangent is just going to be 1 over x. For this one, label it. Find your missing side. And we get square root of 1 minus x squared. A little practical problem here. A boat is pulled in by means of a winch located on a dock 5 feet above the deck of the boat. Let theta be the angle of elevation and s be the length of the rope. You can see them labeled here. Write theta as a function of s, and then put in some numbers. Pause the recording, give it a try, and resume to check your answer. Okay, theta is going to be, the sine of theta is 5 over s, so theta is the arc sine of 5 over s. And putting in the information, we get 0.13 and 0.25.